Welcome back to day 2 of the Flexsim core training. We'll begin with chapter 4, building models using process flow, where we will be introducing the process flow library and talk about things like tokens and activities and shared assets. We'll work our way through modeling exercise number 2, which is composed of 5 phases. Process flow is characterized not by objects, but by individual activities or events, similar to the individual properties defined on objects, but more standalone. By design, it's a more abstract environment. No object-like visuals tying you down to locations or distances, and therefore much more flexible than object modeling. So its strengths are the level to which you can customize it. It's highly customizable, very flexible, and is a centralized logic approach. In other words, your logic is all in one place, and it's much easier to see what's going on. This is a screenshot of an actual process flow. You can see it's made up of individual activities like palette source, create palette object. These are individual activities. They're kind of grouped in a block of activities here. Further, they're put into a visual container for organizational purposes and given a title. These slightly different colored ones over here are resources. You can see how things are connected together with connectors or just combined together in a single block. These green things are tokens. Let me demonstrate to you a little bit of the process flow. Let me go up to the process flow button on the toolbar and add a general process flow. Now this is all abstract. In fact, I don't even need the 3D model if I don't plan on making any 3D objects. Okay, so on the left are the activities. I'm going to drag out an inter-arrival source, and that's what it looks like. And let me put out a delay and then a sync. Line them up. Okay, if I start running the model, I see tokens arriving in my source. They're not proceeding because I don't have a connection, so I can make connections. Mouse up here and see my cursor change to a link. Click on this, didn't drag it down, it'll snap to the delay. Make this connection. If I click on the delay, all it has is a field to define a delay time. We can choose a distribution just like we've done before for processing time. But this is very abstract. It's not associated with any physical objects. Reset and run the model. Now I see my tokens come through, and there's a little animation on the surface of the token to show the progress through the delay time. 2 tokens being processed currently. Now what if I wanted to add a second delay activity to my model? I should probably stop it, reset. I can't make 2 connections out of the source. That's not the way it works. You get 1. If you want to make a decision, remember we had the send to port field before. You could put multiple ports on it, but now each of these little blocks, they do just something very specific, one specific thing. So we would need to use a decide. That could, I guess, represent the send to port field we had before. And now break this connection, put it into the decide, and let the decide figure out which of these to send to. And then you have a field here that says send token to, and you define logic for that, maybe by percentage. So this starts to look familiar here. But it's all visual what you're doing. See all your connections. So, in summary, the process flow tool is the main tool that you'll use to build the logic for your simulation model. Process flow tool allows you to build a flowchart of your model's logic. And inside that flowchart, you'll add activities, like we've done here, that contain small chunks of pre-programmed logic. And when the simulation model runs, small green circles called tokens move through the process flow activities, executing each activity's logic. You can edit the activity's properties to link these activities to the objects in the 3D model, or you can create a self-contained simulation purely inside this process flow tool itself. As an example of linking, you could link a token to a flow item in the simulation model if needed. Okay, let's talk about the three pillars of process flow: activities, tokens, and shared assets. An activity is a logical operation or step in a process flow. As such, activities are the basic building blocks of any process flow. Activities are dragged from the library into a process flow window and linked together with connectors. As a token enters an activity, it performs the logic associated with that type of activity. Activities can include assigning labels, moving flow items, delaying a token, etc. In some activities, like the assign labels activity, the token will start and end in the activity with no time passing in the simulation clock. While running a model, the token will not be visible in that activity. However, we can use the step button on the simulation control bar to step into it and see this time. I should point out that connectors can be used to connect activities together, such as in this example here, the decide has two connectors coming out of it, one going into the batch activity and one going into the delay activity. It's also important to note that activities can be connected together by just being slid up next to each other, and they'll snap together. And so this is called an activity block. It's made up of 1, 2, 3, 4, 5, 6 activities. It's as if a connector was going between all those blocks. So it's up to you as the modeler. You can organize it any way you want. Okay, tokens. Tokens are markers that flow through the activities in a process flow during a simulation run. They function very similarly to flow items in a standard 3D model. Like flow items, tokens move from one activity to the next, much like a flow item moving from a source to a queue to a processor and so forth. But unlike flow items, tokens do not necessarily have to represent a physical object moving through a business system or whatever you might be modeling. Tokens can be more abstract, meaning they can represent anything you want them to represent. For example, they can represent a customer's order being placed, a call to a call center, a logical grouping of pallets, or just simply a marker for where you're at in a process flow. So that's where they're called tokens, not something like parts. At its most basic level, a token is just a bundle of data that is moving through a process flow. Each token can contain a ID, and when a token is created using one of the token creation activities, one of the source activities, it's automatically assigned a unique ID number. It's also given a name and labels. Labels are essential to building a complex and dynamic process flow. Labels store custom information on a token that can be used to affect what happens to that token as it advances through the process flow. Various activities might assign data to a token's label as it moves through the activities in a flowchart. Okay, shared assets can be used to create and manage lists, resources, and zones in the simulation model. Okay, let me explain more about these shared assets, like resources, zones, and lists. A resource shared asset represents a limited supply of some resource that can be acquired and released. It can be used to simulate a supply of goods, services, time, material, employees, etc. It is acquired and released with the acquire resource activity and the release resource activity. The acquire resource activity is used to acquire a resource at some point during a process flow when a token enters the activity. and the token cannot leave until it has acquired the amount of the resource specified on the acquire resource parameters. When a resource has been acquired, it reduces the supply of that resource by a specified amount that you specify as the modeler. The release resource activity is used to release or return a resource at some point during a process flow. When a resource has been released, it increases the supply of that resource by a specified amount by you, the modeler. Okay, let's talk about the zone. The zone keeps statistics for a group of activities within a process flow. And optionally, it can restrict access to those activities based on the tokens within those activities, how many tokens and or what their attributes may be. The enter zone and exit zone activities are used in conjunction with the zone resource. The enter zone activity is used to define the point in the process flow where the token will either enter or request access to enter the zone. And the exit zone activity is used to define the point in the process flow where the token will exit the zone. Okay, the list resource. It represents a list of things like tokens, flow items, task executors, numbers even, strings, etc. Process flows can use a list that is local to the process flow itself or could be tied to a global list in the simulation model. The two activities that work in conjunction with a list are the push to list activity and the pull from list activity. As the name suggests, the push to list activity is used to add tokens, flow items, task executors, numbers, strings, etc. to the list. And the pull from list activity pulls things from the list. It can cause delays for the claimers if demand exceeds availability. So if the pull from list is trying to pull more than has been pushed to the list, it will block and have to wait till it can pull what it needs from the list. Okay, it's now time to build the first phase of our second model. The purpose of this phase of Model 2 is to gain practice building a model using the basic process flow activities and resources. The description. Create a process flow model that produces a token that represents a part in a manufacturing process at a rate of exponential 0, 30, so an average of 30 seconds. The part will execute delay activities that represent inspection, painting, and curing processes, which must be done in that order. So we'll have 3 delay activities, one for inspection, one for painting, and one for curing in series. Go ahead and use the default distribution for the delay time, just for simplicity purposes. Assume there is a single resource available to conduct the inspection, and a separate single resource available for painting. But up to 3 parts may be cured at one time. So the 3 parts can be cured in parallel. Once curing is complete, the parts may leave the system. As a tip, use the flow chart containers. It's in the visual grouping of the process flow library. Use that to help organize your process. Containers, they look like this. They're in this flowchart group of the library. Just use this one here called the process. Has no logic associated with it. Drag it out. Give it a name like inspection by double-clicking on its default name. And then any activities that are inside of it will be grouped with that container, and you can drag then the container around in your view and all the activities go with it. The other nice thing about these containers is you can connect a flowchart connector going into it and coming out of it. And it'll automatically know that, for instance, this connector here is really going to be connected to this acquire activity. Okay, in process flow terminology, a shared asset represents the need for some outside resource, such as a tool, operator, machine, etc., to be available in order to continue token flow. The resource is abstract by default, It's, for instance, just a number, a quantity of something that gets acquired and released. But it can also be used to represent objects in the 3D model. So as the token progresses through the process flow, if it comes across an acquire activity, then it will try to acquire a certain amount of the resource that the acquire activity is tied to. If it can acquire it, it'll proceed. If it cannot acquire it, it'll wait. Now you can have a max wait timer set on the acquire activity that will say, after waiting so long for a resource, if you do not acquire what you need, continue on. But typically the token just stays in the acquire until it can acquire the resource, and then it proceeds on through a series of activities, and then somewhere downstream it'll hit a release activity and it'll release the resource. Let's take a look at the resource in the software and how it's used in a process flow. So I will create a general process flow and go to the shared assets here in the library and drag out a resource. Now the shared asset, as mentioned earlier, represents an asset with a finite supply that can be acquired and released. For example, 3 manufacturing stations might all share one tool. The tool is modeled here as a resource. When a station uses the tool, it would be acquiring the resource. Once the resource has been acquired, nothing else can acquire it until the acquiring token has released it. So a resource is acquired by an acquire resource activity and released by a release resource activity. Those are activities over here in the library. Acquire resource, release resource. Now to demonstrate this, let's build a simple process flow that begins with an enter arrival source, then a delay activity, then a termination point, or what we call a sync activity. We connect these together. Okay, this source, enter arrival source, is generating tokens using an exponential distribution with a mean value of 3 seconds. So approximately every 3 seconds a token arrives, goes into this delay block, and is processed, if you will, using an exponential distribution with a mean value of 10. So if we run the software, run the model, we see tokens come in, delay, and leave. And depending on the arrival rate and the delay time, you may see more than one token in the delay block at a time. Now, let's say that each token, before it can start its delay or process time, let's think of it as it must capture a resource. So I'm going to drag out an acquire resource activity, slide it up above the delay block in the flow, let's connect it in, and then use a release resource activity and release right there after the process time. Now notice this little icon here, an exclamation point and a red circle. If I hover over that, I get a sampler tool. This is a quick access to being able to sample what resource you want associated with this acquire activity. Or you could click on the properties and do it here. So it's showing the reference. The name of our resource block here is resource, so that's what it's referring to, resource right there. The quantity is the amount we want to acquire. We want to acquire 1. Okay, let's run the model and see what that looks like. You notice how just one token at a time is allowed in the delay block. And we can see the progression of the process time in the animation across the surface of the token. If I click on the token, I can see it is tied to this acquire marker over here on the resource block. If I click on one of these tokens in the acquire resource activity, it shows it's tied to the red marker, which is showing me the current count of tokens that are wanting to acquire a resource. Okay, stop. Let's look at the resource properties. The reference for what resource it is numeric. Very abstract. It's just saying we have a count of 1, and we could think of it as a tool if you want, but it could be like energy or power, something a little more non-discrete, in which case you define its count. It doesn't need to be a whole number. It could be a fractional number like 5.3. And then in the acquire, we could be acquiring a fractional amount of 0.36 and see how that works out. So when the resource operates in numeric mode, it simply keeps track of a number in determining its availability. This number starts at 0, and when activities acquire the resource, it increments the number. And when activities release the resource, it decrements the number. If an acquire activity is requesting a quantity that is greater than the resource has available, as defined by the count property on the resource, then the token will be unable to acquire the resource. Now, resources could also be tied to a 3D object in the model, in which case they would be discrete. Okay, it's now time for you to try to build this model on your own. I'll show you how to build Model 2 Phase 1. Let's begin with the general process flow. We're going to do all our work in the process flow window. I'm not going to use the 3D view. Okay, we've learned how to drag activities over from the left in the library. Here's the one we want, an inter-arrival source. We can also double click over here. And here's the inter-arrival source. I'm going to use this method. It's a little faster. Okay, I'll make a resource. They're down here in the shared assets. If you mouse over, it'll tell you the name of it. And of course, you always can drag from the left, where you get the name displayed constantly. Okay, that's the resource. I'm going to rename this resource the inspection resource. Resize it, and the text automatically sizes accordingly. Okay, I will drag a connector from the source down, release it, and I will start off this inspection with an acquire resource. I can connect it up to the resource immediately. Now I can click and drag a connector from here. A couple ways I can do it. I can click and drag a connector, release, add this delay block, or delete that. I can double click, create the delay block, and then slide it up and it'll snap in. Or I can do what I did up above, click and drag and release and make the delay block. And then snap up. We'll take that connector line away. It doesn't need it anymore. And we were told to use whatever the delay time, default time is. And if I look, it's an exponential 10. Okay. And then I will make a release block. So I can just double click on that line there and make a block, an activity, release, and it'll automatically snap up to it. Okay. Now in the acquire, it's assigning to a label of the token a label called resource, a reference to the resource, and then in the release it's also referencing that label called resource on the token so it knows who to release. So I don't need to edit anything. All I had to do was click on the little exclamation point here and hook it up to the inspection resource. Now we were given a tip to use the flowchart containers to help organize the process flow. So the containers down here in this display group, there's a list of a bunch of different shapes of containers. Choose this one here, and let's resize things. Okay, and this is inspection. Before I rename it though, I'm going to use Control-C to copy it, and Control-V to paste, and make one more so that we have one for painting and one for curing, and then we'll edit them as needed. So here's another thing you need to know. The connector lines, you can connect to an activity inside this container, but what's really cool, I think, is delete that. Make your connection line go to the container itself. Why is that neat? Well, these containers have some properties over here to hide the contents at certain magnifications. Let's see what 50% is. If I zoom out to a certain point, see how the contents are hidden and just the name of the containers in the middle? In large models with large process flows, that might come in handy for you. Okay, click and drag to here, click and drag to here. We're going to click and drag to a sink. This here. We'll rename these inspection. This one is painting, and this one is curing. Notice how it's already connected up to the acquire, the resource is. I'm going to rename this painting resource. Rename this one curing resource, and my renaming's done. Now, because all the process times and the delay blocks, we're going to go with the default delay time for simplicity. We don't need to edit that. The only other thing we need to edit is the curing says 3 parts can be processed at a time. So let me click on the curing resource, and instead of a count of 1, I'll move it to a count of 3. The acquire is asking for 1. So 3 will be able to be acquired. Let's see how it works. Reset, run, step it. Waiting for our first part, represented by that token to finish. It finished, went into painting, finished, went into the curing, and left. Because it's an exponential distribution for those delay blocks, each part is taking a different amount of time. It's quite random. Some are going pretty quick, some are going slow. I'm waiting to see if we get more than 1 part curing at a time in the curing block. There's 2 that are being cured at a time. Okay, looks like it's working. Okay, we're going to jump right into phase 2, model 2. This will give us more practice in using process flow activities and resources. You're going to use the same model that we used in phase 1. Start with that and then create a separate activity flow for another part that will also be produced at a rate of exponential 0, 30. This part executes delay activities that represent cutting, inspection, and polishing. So phase 1 part was inspection, painting, and curing. This one you'll do cutting, inspection, and polishing processes, and they must be done in that order. The inspection process for this part and the part from phase 1 need to use the same inspection resource. After polishing, this part leaves the simulation. The tip is to use copy and paste. It's a good way to quickly replicate similar activity blocks, but make sure things like resource links go with the right resources. Okay, it's now time for you to try to build this model on your own. Alright, I'll now show you how to complete phase 2 of Model 2. We're starting with phase 1 here. Let's make our window bigger. I will shift, click, drag to select everything here in phase 1. Then type Control C to copy. Put my cursor here and Control V to paste. And I can at this point move everything as a group. Okay, let's just rename some things. This is going to be cutting. This is inspection. And this is polishing. Cutting resource. We do not have a separate inspection resource. We were told to use the same inspection resource for the part in phase 1. So I'm going to delete this and then rename this polishing resource. Okay, what do we need to edit? Well, this acquire is still connected up to this block here that we have renamed. It's numeric, has a count of 1. That still applies. On this one, we're going to connect up the acquire to the inspection resource of phase 1. Release doesn't need to change. And then for polishing, we need to change it because previously curing had a max count of 3, whereas this just is a count of 1. That's all we should need to do. Let's reset, run, speed it up, and see what we get. See, we wait for inspection quite a bit more. And we never have more than 1 being polished at a time. All appears to be working great. Okay, we're going to add phase 3 to this model. Here's the description. Use the same model and then create a separate activity flow for a third part that's also produced at the rate of exponential 0, 30, like the other two parts. This part executes delay activities that represent cutting, painting, curing, and inspection, to be done in that order. Tokens in this flow need to use the same resources as the tokens described in phases 1 and 2. After inspection, this part leaves the simulation. So, basically you're going to do some copy-paste, a little rearranging, renaming, and then consolidating some of the resource blocks. As for outputs go, here's the question. What is the throughput rate per hour of each part type? Okay, it's now time for you to try to build this model on your own. I'll now demonstrate how to build Model 2 Phase 3. I'm beginning with Phase 2 as we left it. Let me expand the window. I will begin with a source. I can copy and paste this source here. Click on it, Control C, click over here, Control V. We were told to use the same inter-arrival time of exponential 0, 30. The first step is cutting. I'm going to copy and paste this cutting step, Control C, Control V. I'm going to remove the resource because we were asked to use the same resources used in the previous flows. I'll resize my container and make a connection. Okay, The next step is painting. I'll click on this painting block, Control C to copy, Control V to paste, and remove the resource, and resize. The next step is curing. Click on this curing block here, Control C to copy, Control V to paste, remove the resource, and resize the container. And the last step is inspection. Click on this inspection block, Control C to copy, and Control V to paste. It already does not have the resource. And then make connections between these containers. And then the final step is to send the token to a sink. And it's this one here, the sink. Okay. Now let me check the acquires and releases. Start up here with cutting. Click here. Use this sampler, or I could have not even gone into properties and used this sampler. So I want to use the same resource that's being used by cutting elsewhere in the model, which is this one here. And the release, nothing I need to do to it because it releases per the reference written on a label called resource on the token that was assigned up here. Token.resource. Okay, this acquire block, I'll click here and choose the painting resource over here. For curing, click the sampler and click on this curing resource here. Inspection is already linked to the correct inspection resource. Okay, that finishes that. Now let's create the dashboard needed to determine the throughput rate per hour of each part type. Okay, let's add a dashboard, and let's use output per hour as our metric and display it as a bar chart. Now we need to look at throughput of particular objects in our process flow. We'll use the sampler. We'll sample each of our 3 sinks. I think it might work better if we rename these part 1 and part 2 and part 3. This will be better than them all being called sink. Then I can more easily see what I'm doing here. Let's close that and reopen it. Now it shows my part 1 sink. Let me choose this sampler for the second sink for part 2 and third sink for part 3. Okay, settings. We can choose to not show the legend, text, put a custom title if we want, colors, etc. But let's just go with the defaults and reset, run. Let's see how our model's working. Okay, we would expect our throughput to be similar for the 3 part types since the inter-arrival time of each of the 3 part types is the same. So we're in the 120 parts per hour range for the throughput of each of the 3 parts. Looks like everything is working correctly. Okay, I'd like to use this simple flowchart to discuss 2 different ways of mapping out the flow. Let's assume this is a job shop where you have multiple types of product that use the same resources but in different sequences. So in this example we have 3 part types. Part type 1, shown in red, begins at station 1 and then needs to go through a process at station 3 and finishes. Part type 2, the green line, needs to hit station 2 and then be processed at station 4 and then ends its flow. And part type 3, shown in blue, begins at station 2, must then go to station 3, and then to station 1, and ends. So this is one way of mapping the flow, where you just show all your resources once, and you show, maybe using different colored lines or whatever, the flow through those resources. Now we'll assume that each of these resources can only process one part at a time, so you would have to control that. In the 3D modeling that we did initially in the training, we looked at things from the point of view of the station. We created a station 1 resource block in the 3D view, and then we connected it up with routing lines to all the downstream stations. And then it was the job of the station to decide where to send the part next based on what part type it was. And that could get very complicated if you had a lot of different part types and a lot of different stations and sequences to follow. Well, now let's look at the other approach, which more closely mimics process flow. So, as an alternative, we could list each part type showing its flow separate from the others. Part type 1 hitting station 1 and station 3 and then ending. And then part type 2 hitting station 2 and station 4 before completing. And part type 3 hitting station 2, then 3, then 1, then completing. Same flow shown on the previous slide, but this is a lot more organized. It's a better visualization of the sequence. Just requires a little different thinking. We would have to control the use of any given station by one part at a time, and the way we could do that is by acquiring that station. For example, part type 2 and 3 both have station 2 in their sequence of flow. Well, we would want to make sure part type 2 could acquire station 2 before it was actually sent to station 2 and begin its process time. And then same with part type 3. So by this idea of acquiring a resource, and then when you're finished with it, releasing it can solve that problem, and it makes for a much easier process flow. We're going to continue working on Model 2 by adding a Phase 4. Like the first 3 phases, the purpose of this phase will be to gain practice building a model using basic process flow activities and resources. And we're adding labels to this phase. Here's the description. Using the same model, unify the 3 flows such that the phase 1, 2, and 3 tokens each represent a different type of product produced in the same workshop. Use a single source activity to create parts using an exponential 0,15 inter-arrival time. Use an assign labels activity to assign each arriving part a random type label. That'll be the name of the label, type, such that each of the 3 types occur evenly, roughly 33% of the time. Use a decide activity to route the parts to the flows already created in phase 1, 2, and 3 based on the assigned type label values of 1, 2, and 3 respectively. Those values will be assigned using the assign labels activity, as specified here in the 3rd bullet. The question is, what's the difference between having 3 source activities versus 1 source activity? Previously, our 3 source activities were using an inter-arrival time, I believe, of exponential 0,30. So previously, 3 separate flows, each generating a part about every 30 seconds, and now we have a single arrival point generating a part about every 15 seconds and directing that part to one of 3 flows. Labels can be assigned to tokens or objects. Some labels are assigned automatically by activities, and some we can designate ourselves with the assign labels activity, like we're talking about here. It's used to assign 1 or more custom labels to a token or an object. The labels can be given any name you want and store any type of data you want. This is what the assign labels activity looks like. It has this little green circle icon with 0110 in it, and we'll say assign labels until you rename it. This is an example of the properties window where 4 labels have been added to the token. See, this is the field where you'll specify what you want to assign the labels to. Typically it'll be the token, but it could be some other object. Okay, this is an example of a text label where the name of the label is text label. I like to not use spaces in my label names. It makes it a little easier later on when you're referencing the label with code. So I suggest not using spaces and not using special characters in the naming of your labels, but do use a capital letter for the beginning of each descriptive noun or verb within the name. Here the example is showing a value of just hello world exclamation point being written to the label named text label on the token. And the next label that's assigned to that token is one called random number, and the value that is assigned to that label will be generated from a discrete uniform distribution with a minimum value of 1 and a max value of 3. Random number stream 0. The next example is a label called static value, and the value is a number 5. And the last example here is of a label named pointer to processor, and as the name implies, it's a pointer to a processor called processor 1, probably out in the model, and probably sampled with this sample button here. Okay, process flow automatically keeps track of any labels you create, as well as any labels created by the activities themselves automatically. Edit fields often will have a menu called token label, as shown here in this graphic. And if you click on it, you'll see a list of all labels on the token that have been defined so far. This allows you to easily choose one of them. So, as I can see in this field here, it says token.customer. That's the syntax for referring to a label on the token called customer. It will write that automatically for you if you choose this menu option and would have clicked on this customer label. Let's talk about the decide activity. It is used to make some kind of decision regarding which activity tokens will do next. It allows for multiple out connectors and the logic for choosing which of those connectors the token will go through to do its next activity. This is what the decide activity looks like, the icon, and it'll say decide until you rename it, which, by the way, is always a good thing to do. Rename your activities so that you can follow your logic better. It'll have a field called send token to. In this image, this down button was clicked on, and then from a list of choices, the conditional decide option was chosen. And this is what the pop-up looks like for the conditional decide. It'll have a field called condition, and then a field called true and false. The condition is an expression. In this example, token.type is a reference to the type label on a token, and it is compared. 2 equal signs are used when comparing, and 1 equal sign is used when setting. Here you're comparing, so 2 equal signs. It's comparing the value of the type label on the current token to the value 3. If it does have a value of 3, this is the field that'll define where to send the token. It can be text as shown here, in which case it's a reference to the name of the connector, the out connector. So of course you must have given that out connector a name called type 3's go here for this to work, and another connector would need to be named everything else goes here. Now these true and false fields need to either have the name of a connector or a numeric value referencing the rank of the connector 1 or 2. Alright, this is an example of a common pick option. It's called the by case pick option, something by case. It allows for multiple outcomes based on an expression, usually a label value that has different potential values. It's commonly used with a label value where integers only can be used to make one or more logic decisions. The case function is an expression with multiple possible values. So in this example here, this is a delay block where we're specifying the delay time. We chose the time by case option by clicking here. This pops up. Here's the field for case function. As mentioned already, it's typically a reference to a label on the token or some other object. In this example, it's a label called type on the token. And this plus button here is used to add as many resulting cases as you need. If type would have the values of 1 and 2, and possibly some other value, which would result in the default case, returning a 0, then if the value was a 1, case 1 is used, and the expression that will be evaluated to define the delay time would be this log normal distribution. And case 2 is a triangular distribution. Now in our phase 4 model, you're going to be using this by case pick option, not in a time field, delay time field, but in the send to field of the decide that we just talked about. Look for a pick option called activity by case or connector by case. And then you'll want to set it up to have 3 cases, 1 for each of the 3 values of the token's type label, a 1, 2, or 3. Okay, it's now time for you to try to build this model on your own. Okay, this is the point we were at the end of phase 3 of model 2. And for phase 4, we simply need to create a single source of items, label them according to their type 1, 2, or 3, and then use a decide activity to route them to each of these 3 flows. 1, 2, 3. Okay, so double click here. We'll use an inter-arrival source as it gave us an inter-arrival time exponential distribution, where the mean value or scale parameter here is 15 seconds. Okay, we can hover right here, and when we have the link as an icon, we can double click and create this activity, the assign labels activity. And we're going to assign labels to the token, and the label name we want to use is type, and the value is based on percentage. We have 3 values, so click the plus button here, and it said equal weighted approximately 33%. So let's do 33, 33, and to make it add up to 100, this last one will be 34, with values 1, 2, and 3. Okay. Next activity we want is a decide activity. It's this one here. And let's delete these sources. Move this down a little bit. We'll create connections in this order. This will be part 1, so I want it to be connector 1. This will be our type 2, which is connector 2. Can you see the connector numbers here? 1 and a 2. And then drag a connector here, connector 3. Now let's look at what we want to put on this decide. Send token 2. Okay, we want to use either this option or this option. Use this option, connector by case. The case function will be a reference to the token label we called type right there. Token.type. And there will be 3 cases. Case 1, 2, and 3 and a default which won't get used. Connector 1 for case 1. We can use ranks or the name of the connector. We haven't named our connectors yet, so we need to use a rank if we don't want to name the connectors. Let's look at how this changes if we do give these a name. Now I can name them through here by double clicking. Go part 1 as the name of that. Or The decide activity actually has that feature to be able to look at what it's connected to and do some renaming of things. Here it's showing us our 3 connectors that are connected up. We've renamed the one already, so you see its name here. But you can go like this. Choose a connector to edit to, and you can name it here, part 2. And see, it even tells you the activity it is connected to, an activity called cutting. And it's the 2nd ranked connector. This is how you could change ranking of connector after having created the connectors if you wanted to. Okay, let's edit the 3rd connector and call it part 3. And it's also connected to an activity called cutting. Okay, now we see our names here. Okay, now let's look at the connector by case, and we could, if we wanted, you could choose activities to send to. We don't want to do that. We could put a name here. Now we'd have to use quotes and say like part 1 is the name of that connector. Okay, but I'm going to keep it the way it was. Let's reset and run the model and see what we've got. Step. So our first part was a part 1, part type 1. And we got a part type 2, a 3. And notice how if I click on one of these tokens over here, it's going to show what all it's acquired so far, and sometimes the lines stretch over here and acquire the common resource, like for painting. We have one painting resource being used for both. All that appears to be working just fine. Throughput per hour, I think we were in the 120 range before. Let's speed it up. Now we're in the 70 range. That's the difference between having that one source like we have now with an exponential 15 inter-arrival time versus 3 separate sources that had an inter-arrival time each of 30. Alright, that's the end of phase 4. Now that we've learned about resources and about labels, I'd like to go back and address the resource again. To do that, I'm going to work in this model here. There's 8 examples I'd like to show you. And they're all in this same model. If I zoom out, you can see the process flows for them all. But I have saved views here to just zero in on one at a time. Most of these examples have a process flow that begins with a source, creating tokens, goes through a delay block, and then there's an acquire and release resource activities, some delays in between. The purpose of these delays is to stop the token long enough for me to click on it and show you some labels on it. So in this first example, I'm using the resource block with a reference type of numeric and a total count value, max count of 1. The acquire is referencing that same resource called resource ex1, ex for example 1, and it's wanting to acquire 1, a value of 1. It's hard to talk about that. It's not really an object or a thing, it's just an abstract numeric value. I want 1 of whatever resource has, and it'll decrement the count of resource by that value. And if it can't get the amount it needs, the token will wait in that acquire block and won't proceed. So let's watch that. When the token is in the delay block, I'm going to stop. Let me step up to where an item comes into this example. Okay, there it is. If I click stop and then go click on this token and look over in quick properties, no labels are defined on that token yet. Let me start running again. Okay, the token has gone through the acquire activity. And it's showing it has acquired a value of 1 from this resource. If I click on it, well, it's already clicked on. You see the labels here? It now has a label called resource, and the value of it is 1. Well, it's the acquire block that created that label on the token. And it's all due to this field here called the assigned to label field. And the assigned to label is called resource. on the token.resource. So the token is going to acquire the resource, maintain its claim on the resource until a release activity is executed, and by default only one token may claim a resource at a time. By default, those are just the default settings. Another interesting thing we can do is look at stats for the requesting and claiming tokens. So let's run it a little longer. Let's go ahead and speed it up. Okay, we got several parts going through. It looks like we have 144 tokens trying to acquire the resource right now. Let's see. Click on the resource name, and then over here in Quick Properties, if I click on this little button here, I can view this activity's statistics. Okay, input. Current is 440. That's the current value of the input. 440 things have been acquired from this resource, and 439 have been satisfied and left. The content, average 0.98, it has stay time. These are general stats you'll get on all activities, so some of it's not all that interesting for a resource blog. How many requests? The request stay time, so on average, requests had to wait 887 seconds so far to get what they needed. And the max available resource is 1. That's going to match the count value on the resource. The average available resource is 0.02. Okay, now let me jump to the example 2 view, and this is just pointing out that resources have a count property. It allows for multiple claimers on the resource. This example has a count value of 3. The acquirer is still acquiring just one thing, so we'll see that 3 tokens can have something acquired from this resource simultaneously. The count field is also a way to create an abstract pool of available resource such that a single resource block can represent many acquirable components. Okay, let's look at the labels of some of these tokens that have gone through the acquirer. They have a resource label and it's a value of 1. Now let me jump to example 3, the quantity property. So the acquire quantity property allows a single claimer token to try claiming multiple resources. But this is really not as abstract as I'd like you to think, because this acquire, yes, it's acquiring 2 something from the resource. It's really just a value. It doesn't even have to be an integer. It can be like 0.6 or something. Let's not change that yet. And let's look at the label on this token, and we would expect it to have a label called resource with a value of 2. I'm going to change this to 0.5, something I can keep track of a little easier. Reset, run it fast enough to get some stuff through here, and stop it. Now we look at this. It has a value for the resource label of 0.5. Needs 0.5 of this, so the total count's 3. We could actually have how many tokens acquiring something simultaneously from this resource? Well, we could have 6, total of 6 tokens, because each token just needs 0.5. Okay, let's look at example 4. On this resource block, we have a count of 3. We're acquiring 2 things. And so what we want to learn from this example is an acquire activity assigns a label to the claiming token, which allows the token to keep track of information related to what was acquired from the resource. Okay, we've gathered that so far, right? In this example, the value associated with the token.resource label tells how much whatever, and it's a numeric abstraction, has been acquired. Assigning a different reference value to the resource will change the label's value. We've seen that. Okay, nothing new on that one yet. Now, in this example, it's using a different reference altogether. It's not a numeric reference. It's a reference to an object called cube. To see that cube, it actually exists in this 3D view out here. Let me click on the 3D view, and jump to a saved view for examples 5, 6, and 7. Here's the cube. And here's an operator we're going to look at in a minute on example 6. Okay, so you'll see the type is purple. It's an actual pointer to a cube. It's not just the word cube. And this object does have a name called cube if you look over here in quick properties. But it was defined by using this eyedropper. So let me reset the model. You're going to see the color change here. I'll explain that in a minute. This eyedropper was just used to sample an object. I could sample the operator, in which case you see operator here. I could sample this cube, in which case I see a cube there. Now this resource block is no longer so abstract anymore, is it? It is a reference to an actual thing out in the 3D space, a cube in this case. The acquire block, using this here, it was referenced to this, the cube resource ex5 resource block. And we want to acquire one of whatever that resource block is associated with. It's one cube in this case. And we still want to assign it to a label called resource. Okay. Now when I run, whenever a token comes through here and acquires something, it's going to change the visual of the cube to a different color, just so you can see that it is being acquired constantly by a new token. Let me stop the model. This token here has acquired the cube. If I click on it, what does the label show now? It doesn't show a quantity of anything. It shows a reference to a specific object. The path to it even, /cube. It's a direct pointer to this cube. So the resource can be assigned different reference values. The two most common are numeric, that we talked about in examples 1 through 4, and that happens to be the default. That makes the resource an abstraction, representing whatever the user desires. And an object, or even a group of objects. You can set up a group and specify that as something the resource points to, and we'll look at an example of that in a minute, where the resource acts as a stand-in for objects and activities of the process flow. So it's a way for us to associate something here in process flow with physical things out here in the 3D model. Only one token at a time can acquire a thing. It's not like the numeric. Okay, and then on the release, there's two fields that are important on the release activity. It first needs to know how much or what specific, in this case, in the case of objects, what specific object to release, and which resource block is associated with that resource being released. And in this case, last acquired, it's always the default. I didn't look at that on the first couple of examples. Let's go back to example 3 and look at its release. See, that's the default, and it works for that as well. There's more information than just that label called resource on the token. There's information about different shared assets that have been acquired. So you have to specify which shared asset, and most of the time it's the last one you acquired, but it may not always be that. You might have to choose one of these other options. We're not going to talk about that right now, however. Okay, so that's example 5. Now, let me reset the model, and I have a reset trigger on this cube that always is setting the color back to teal, a teal color. Okay, let's jump to example 6 view. A token may acquire multiple separate resources, which will change the value of the reference label yet again, this time into an array. When using default settings, a separate release is needed for each acquire. So see how we're doing an acquire here of the cube, a delay, and then we do another acquire. We now have this resource block tied to this guy here, the operator. And then after a delay, we release resource 1, the last acquired Well, last acquired would reference the operator. That was the last one acquired. So it would release the operator first, and then this one's last acquired would be, the only one left would be the cube. And let's look at the labels. So reset, run. Okay, here comes some stuff. Let's look at this token. It's got a resource label. That's actually an array with a size of 2, and here's the 2 things in the array. The first index in the array, resource array, is a reference to the operator, and the next one is a reference to the cube. And because we only have one operator, you can see there's 2 tokens waiting up here at this first acquire, trying to acquire a cube, because we only have one cube as well, and it's acquired both the cube and the operator. Okay, let me step. Trying to stop it right at, okay, stopped it. Okay, this token here has released the operator. Remember, I said the last thing acquired at this point in time, the first time of the first release, is the operator. So it released the operator first, so you no longer see the operator in the array for the resource label. You just see the cube. And then when it enters this, it'll release the last thing required, which will be a reference to the cube. Okay, now let's jump over to example 7 and see what we can learn from it. Okay, how a resource is released depends on the label created on the token during the acquire activity. This provides a variety of options for how to release one or more of the resources that may have been acquired by the token. In this example, only one release activity is used to release both the cube and operator resource objects, whereas in the previous example we had 2 release activities. So see, we just got the one here. Let's see the way it did it. Still has a reference to the token's label called resource to know which resource to release, and that was assigned to the token out of the resource block. And as far as what to release, instead of the default, which is last acquired, choose this option here that releases everything. The way it does that is goes through the array of all acquired things by the token and releases them all. Okay, let's look at the last example, example 8. Now example 8 uses a different set of 3D objects over here. Well, let me jump to the view because I have a saved view right here, example 8. Okay, it's made up of a cube. It's a different cube. It's called cube 2. You see the name of it here. And has an operator called operator 2. The other one was just called operator, and there's actually 4 here. This one's operator 2, and this one's called operator 2 underscore 1, underscore 2, and underscore 3. And if we look at this resource block here, the operator resource ex8 block, it originally was just sampled. The reference was defined by sampling this operator 2 object. The count was set at 4, and these resource blocks, if they are references to a specific object, when you hit the reset, if there's not 4 of whatever object you specified, it'll create 4. So that's kind of nice, and that's what's happened here. Okay, so if I click on this token right here, we see it has a label called resource, and it has acquired the cube. It also has a label called weight. I'll explain that in a minute. And then when it goes through this block, it'll pick up a reference to the operator, one of the operators. Let's see if I can run it and stop it after it has, okay, stop. It has now acquired one of the operators. Which one did it acquire? Well, click on it. We can see the resource label is an array of 2 things. The index 1 in the array is pointing to operator 2 underscore 3. So it chose this guy here that we have highlighted when it went through the acquire block. Had all 4 to choose from because no one else has currently acquired any of them. or it'd say 2 things have been acquired, up to 4, or if any are waiting, trying to be acquired, they'd be red here. Okay, so how did it choose operator 2 underscore 3? Well, that's the purpose of this example, is to show you that there's queries you can write for the acquire process, where you use order by to sort the things you're trying to query from. It's like an SQL or SQL query in format. Order by queries are permitted for both the claiming tokens, these tokens going through trying to claim or acquire something. They can execute a query to decide which of many to actually acquire. And the resource itself can use a query to look for waiting tokens once a resource does become available. When this cube, there's only one cube and the count is 1, and it's been acquired already by this token here. See the line showing 1 acquisition of the cube. There's 5 tokens, and here they all are here. There's 5 requests currently on back order for a cube. So when this cube gets released, this cube resource has to decide, well, which one of these 5 requests do I give it to? Do I satisfy? And if I look on here, it's this field down here called the queue strategy. It's where you define a queue strategy with an order by statement or some other means for the requested acquires, or in other words the back orders. And it's saying order by puller.wait. Puller is a reference to the thing trying to pull a request. It's the token, if you will, but these are pullers, and it's using the wait label, and it's sorting it in ascending order. So highest weight is at the top, and so whichever token has the highest weight, it will allow that one to acquire the cube. If I click on these tokens, I can see what their weight is. This one has a weight of 788, this one 587, so they're varying. And that was done up here with this assign labels. We're assigning a label on the token, giving it the name weight, and giving it a value between 200 and 800, uniformly distributed. So that's a query for the back orders. Let's look at where we used a query to define which one of the 4 operators to choose. Well, that'll be on this acquire block. Resource reference is the operator resource exa block. We want one of them. This is the label we're assigning it to. All that is standard. And then here we wanted to order the resources, the operators, based on a priority label and in descending order. So that puts the highest priority at the top. Oh, I spoke wrong on the weight. Ascending means getting larger, and so the top of the list would have the lowest weight. Yeah. Whereas in this case, we want the operator with the highest priority. Well, where's that label? Well, it's a label on the resource that's being acquired. We have to go look at that. So in this model, each of these different operators has a label on them. If I click on this guy, come over to the quick properties panel, I see it has a priority label of a 3. And what's this guy? Priority 1, priority 2, priority 3, and priority 4. This guy had the highest priority, and so since all of them were available, the token chose this guy, the highest priority, because they were all sorted by their priority. Okay, I was going to show you what happens if let me reset the model. You should always have the model reset before you edit something. And change the count to a 3. Reset the model. Remove the guy. Set the count to 5. Now it's not going to spread them out, but you'll see what happens. When I reset the model, it creates them, but they're put in the same spot as the original guy, operator 2. And they're at it named them with the next available underscore numeric name. What did it do for the labels? This guy has, these both have a label matching the one they were copied from. So you'd want to go and manually change those to keep up the same scenario where you're choosing based on a priority. Alright, very good. Hopefully this was helpful in learning a little more about labels and resource blocks. We're now going to look at what's needed to complete the fifth and final phase of Model 2. In the first 4 phases, we worked entirely in the process flow space. And now we're going to work in combination with the 3D space and the process flow space by implementing 3D objects for the job shop, with both a simple object approach and a more advanced approach using event listening. We'll use 3D cues as the process locations, and then acquire those as resources and move the items or parts into each object. The layout will look like this. It'll have these 6 cues. These 5 cues each represent the different processing steps that we already have in our process flow. This cue here, which we're calling inbound parts, is a place to set the parts when they first arrive. And then according to the 3 part types, they'll be moved into one of the 5 processing locations in sequence as already defined in our process flow layout. Okay, let's take a look at the activities that will be used to control object behavior and to control object appearance. To control object behavior, we have these 3 here that will be used quite a bit. One is called create object. It, as the name implies, will create an object out in the 3D space when a token enters it. This one here will move a 3D object. And this one will destroy it, take it out of the model space. This one here, which can only be used with task executor class objects in the 3D space, like operators that walk, AGVs that travel, any kind of mobile object is typically called a task executor class object. You can use these kind of activities like travel. There's one to move it into or something into it, load something, unload something. There's a lot of different task executor specific activities. We'll take a look at those in the future. You won't need that one for this phase 5 of the model. Okay, and then there's a couple activities I want to introduce to you for controlling object appearance. One is called change visual, and it can change a lot of visual attributes of a 3D object, like its color and its size and rotation. This one here will start an animation running. So when you see people walk in the 3D space, that's because an animation has been started on them called the walk animation. And task executor type objects have lots of different animations you can apply to them. Okay, this is what the layout looks like for the second part of the phase 5 challenge. You're being asked to use a 3D processor object, that's what these green ones are called, processors, to simulate the processing time of the different activities. Whereas before we were using a delay activity in the process flow itself to represent the processing time, you're now going to use this 3D object. There's one for each of the stations. So this is the one for the inspection and polishing, etc. For the curing, notice you'll need 3 to represent the fact that 3 parts could be curing at the same time. They're called curing slot 1, 2, and 3. Okay, you'll need to learn about event listening in order to complete this last challenge of phase 5. Event listening allows tokens to be affected by things happening elsewhere in your models, such as out in the 3D space. Delaying a token using like the wait for event activity, or creating a token using the event triggered source when an event takes place is how it is done. Where previously we were using a delay activity to represent the processing times, we're now going to use an actual processor object where you define processing times on the object itself like we did in day 1 of training. That's what you'll use to represent the different processing times in the model. I'd like to demonstrate the event-triggered source and the wait for event activities in the software now. Let me create a process flow, a general process flow. This will be a simple post office model. Tokens arrive and wait to be processed at a single server. So here's our inter-arrival source we've used before. Has an average inter-arrival time of 3 seconds. Then I will try to acquire a resource. Let me create a resource. That's this block here. And link the acquire to the resource. After acquiring the resource, I want to enter a delay block where I'll delay for an average of 10 seconds. After that is finished, I will release the resource and remove the token from the model. Okay, let's just check that it's working as expected. Okay, tokens arrive. They end up queuing in this activity that tries to acquire the resource, because if they can't acquire the resource, they naturally will back up. So that kind of acts as our queue. This acts as our server with a process time. Okay, now let's make a similar model in the 3D space. Begin with a source, then a queue, then a processor, then a sink to destroy the flow item. Now I will connect those together. A, click drag, and let's make the inter-arrival time of the flow items use the same distribution as the arrival of tokens. So it was an average of 3 seconds. And the processor will have a process time of a statistical distribution. Exponential is what the delay block is in our process flow, and 10 is the average. Okay, I could have edited that over here. Okay, let's reset and run the model and see what we got. Exact same distributions for arrival rates and processing or delay times, but you won't see the exact same thing happening over here as over here, because different order of random stream generation. Okay, now what if I wanted to link these two models? For instance, what if I did not want to generate my own source of tokens? So let me delete that and set that over to the side. It won't even be used. And instead generate a token whenever this source out here generates a flow item. To do that, I would use this source here called an event triggered source. Use this sampler to sample this source out here. Now it's a question of which event on that source do I want to trigger off of, and it's shown me all the pertinent trigger points on that fixed resource source in the 3D model. The one you'll want to use most of the time is the send to port event. It happens after all other events have happened on the object, and it has released the flow item and then tries to send it out through a port. And this is true whether it has a port or not. It's the last thing that happens, so that's a good one to use. Now if I'll click over here on the icon of this event triggered source, I'll see what got written to the parameters. The object we're listening to is the source, and the event is send to port. And then you have this label assignment / match value table that you can choose to use if you want. It'll be populated with different things depending on the object and the event you're listening to. Its main purpose is to pass information about the event and the objects associated with the event to the token. Another purpose of this table is to compare whether there's a match between the token in the process flow and the flow item that triggered the event. Okay, now let me hook this up to the acquire, because a token will be generated every time a flow item is generated. Now let's see what it looks like. Sure enough, every time I see one created on the left, I'm seeing one created on the right. The process times do not match up because they're using different random number streams. Okay, stop. That's how the event triggered source can be used, and I'll let you use your imagination as to how that might come in handy for different modeling situations. It's a way to get a token created based on some event out in the 3D space, or an event on an activity within your process flow if you want. Okay, let me delete that. Go back to this, my own source of tokens. And let's assume that I'm not going to use this source anymore. So let me delete that. I'm not going to use this sync anymore. And in fact, I'm not going to use the Q to processor connection anymore. So hold Q down and drag from there to there and break that connection. And all I'm going to do is whenever a token wants to use the processor, I'm going to move a flow item into the processor. And I'll begin by creating a flow item and putting it in the queue right off the bat. So right here, I'll double click on the line, the bottom line of the source, and I'm going to choose this activity here to create an object. And after the object gets created, which will be a box, quantity of 1, I'm going to put it in, not the model, but I'll use this sampler to sample the queue and say, put it in the queue. And assign to it, or assign to a label on this token in the process flow, a reference to the item that is being created, the box, the flow item. So now I have a label on the token I can use if I ever need a reference to the flow item it created when it passed through the create object activity block. Okay, now we'll enter the acquire, the resource, and then it'll go into this delay block, but before the delay, I want to use this move activity, or move object activity, to move the flow item in the 3D space into the processor. So the thing I want to move, the object I want to move, I can reference with the item label on the token, and the destination will be set to this processor 1 object. It'll delay for the process time and then go through this release block to release my resource, and then I want to delete the object. Destroy object is the activity I want to use. Put it right there. And the object I want to destroy is the flow item. Once again, I'm using the item label on the token to reference that. Alright, let's see if that works the way we expect. Okay, it's creating flow items and putting them in the queue every time a token passes through here. They're waiting to acquire the processor. Once they are able to acquire it, it'll move the flow item into the processor, delay, release, destroy. Cycle repeat. Okay, let me stop and reset the model. Now let's make it a little more sophisticated. Let's assume I want to use the handshaking that takes place between a queue and a processor, to where the queue will automatically push or send a flow item to the processor when the processor is able to receive it based on its constraints of capacity, which by default is 1, max content of 1. And we'll use the processing time on this processor to process the object and won't use a delay block anymore. So what can I get rid of over here? Well, I don't need to acquire. That handshaking will be done out in the 3D space, and I don't need to release. Don't even need that block there. I will create the object, place it in the queue, and then, let's get rid of our delay block. Okay, to actually make this model make a little more sense, let me add another queue. This will be like my landing spot that I will place flow items in right after they're created. So let me change this to say place it in this one here. And then I won't use a connection between here and here. Instead, I will use this move object to move the token into the queue in front of the processor that I want it to be processed on. And then this handshaking with the port connection will automatically, as mentioned before, send the token over into the processor when it can, when the processor can accept it. Otherwise, you'll just see them pile up here. Now, how do we know when the processor has finished processing the flow item? Well, let's add this wait for event activity to do that. Once again, I can use this quick sampler tool to have it do most of what I want, and that is click on the processor to choose it as the object to listen to, and I want to listen to the send to port as mentioned earlier to know when this processor is totally finished processing the flow item, has released it, and wants to send it. Let's take a look at the parameters for the wait for event activity. By using the eyedropper to sample the processor and event, it filled out the top two fields for me: the name of the object I'm listening to and the event I'm waiting for. Let's talk about this table, the label matching / assignment table. We briefly mentioned it when we talked about the event triggered source, where it has two purposes or options. One is to set a label on the token based on the information passed from the event. Each event type will pass a different number of parameters. In the case of the send to port event, it just has the one parameter in the table, a reference to the releasing item, the item that basically triggered the send to port event, the flow item out in the 3D model space. So let's look at the operations you can do with that parameter. Nothing is the default, or I can assign the releasing item reference to a label on the token. Just come up with any old name you want for the label on the token, like the releasing item. That would record a pointer to the releasing item of the event on this token that's sitting in the wait for event activity. That is one purpose. That's not the purpose which we want to talk about, or which we'll use in the Phase 5 model. We want to use the operation called match. And then we want to use, for the label name here, item. Remember, that is the name of the label on the token that was assigned up in the create object activity as a reference to the flow item that was created by the create object activity. Now, the flow items that are triggering the send to port event on the processor may or may not be associated with this token. So now that we have a match operation in this label matching assignment table, two things must happen for the token to be able to leave this wait for event activity. One is the event must fire. The send to port event must fire out on the processor 1 object. And two, it needs to be the flow item that matches the flow item referenced on the item label of this token. This is a way of syncing up the token in the process flow with the flow item in the model, and that's what we want to use. Okay, when that happens, then I can flow into my destroy object activity and remove it from the model. Okay, let's connect this up as well. Let's see what we've got. Reset, run. We'll never see them in this because they can immediately be sent into this queue and flow on. Okay, with that information, I think you'll be able to do the two challenges in the Phase 5 model. Okay, it's now time for you to try to build this model on your own. I'm going to demonstrate how to complete the simplified object approach model for the Phase 5. First, let's open up a little real estate, close off this dashboard, resize this pane here, and now let's create our queue objects. We need 6 of them. It's this object right here. 1, 2, 3, 4, 5, and 6. Okay, let's rename them. This one here will be called inbound parts. This one will be called inspection station. This one, the polishing station. This one, the painting station. This one, the cutting station. And this one, the curing area. Okay, now we want to adjust our process flow. One of the first things we want to do is, right after assigning labels, insert an activity called create object, this one here. And after the create object, we want to change visuals. So that one is right here. Okay, in the create object, let's take a look at what it needs. It's going to create by default a box, quantity of 1. And where's it going to put it? In the model. We don't want to put it in the model. We want to put it inside the inbound parts queue, this one here. And then we want to assign a token label called item that will tell us what flow item was just created. It'll be a reference to it we can use throughout. That's all we need to do on the create object activity. In the change visual, I want to change the color based on the type of object it is. So we'll add a trigger here to set object color. The object it will be setting the color of is defined by token.item. Perfect, because that's the name of the label we called on the token in the create object activity that points to our flow item. So it's going to change the color of the flow item. What do we want to change it to? Well, let's change it to color by number. And the number that we pass it can be a reference to the token dot type label. Up capital T, this one. Now we need to add some move object activities. So after the token creates an object, change the visual of that object, goes through the decide, then it will go into one of the station blocks here, try to acquire that station, and then go through a delay. Well, right after the acquire is where we want to move the flow item into the corresponding 3D station. So highlight the line in between the acquire and the delay and double click, and it's this one right here, move object, I want to add in there. And need to resize my block a little bit. Okay, this move object. The object it's going to move, what's written in this field already is what we need. Token.item will refer to the flow item. The destination though we want to update. So this destination, let's see, we're in inspection. So inspection is this object right here. Sample it out in the 3D space. Fills it in for us. Okay, we need to just repeat that theme. And the last thing we need to do is add destroy object activities to remove the flow items at the end of the process flow. So I'll just double click, create the destroy object activity, and then drag it in right above the sink. And it knows who to destroy, token.item. Make another one here. Need one for each of the 3 flows. Okay, that should do it. Let's see if it works. Reset, run, step. Okay, our first token is part 1. And part 1 goes from inspection to painting to curing and leaves. That looked correct. Let me speed it up, see if we get any errors. Nope, everything appears to be working good. Okay, that ends this simple object solution. Okay, I saved what I just did in a model called Mod 2 Phase 5 Simple, and this will be my starting point for the next advanced approach model. Okay, first thing I want to do is rename this. Now, for each of these 5 stations, I need to create a processor object. So let's take care of that first. Drag one out for this guy. And for this one, this. For this, move things over. Now the curing one actually has 3 stations, so what I'm going to do is use 3 processors, make them a little skinnier. Copy, paste, and paste. Okay. That's the layout. Now let's rename some things. This used to be called inbound parts. That one's going to stay the same. This one here, inspection station. I'm going to tack on Q to the end of that. I'm going to copy that because I want to paste it on all the others too. Okay, so it's the inspection station Q. This is the polishing station Q. Painting station Q. Cutting station Q. And the curing area Q. Now, let's name our processors. Copy that. Inspection station. Paste. Painting station. Paste. Polishing station. Paste. Cutting station. Paste. And curing area. I'm going to use a naming feature we've got in the software here. Instead of copy paste, I got 3 of them here. If you have them all selected like this, and then come over to quick properties, hit this button here, and type in a name. I'll call it curing, how about slot? Curing slot, begin with a 1 and apply. And now, shift click, this one's called curing spot 1, 2, and 3. Okay, that's our layout. Now for the process flow. Couple changes. Let's first look at the move object command and see if it was updated. It was. Because it's a link, it automatically changes the destination to the queue, inspection station queue. All these move objects are going to move it into the queue, and then the queue is going to use port connections to send it over to the processor when the processor can handle it, as the processor is available. And because all the resource allocation stuff is going to be handled out in the 3D model, we don't need to do it here in the process flow. I'm going to remove these resource blocks. And I can get rid of the acquires and releases. If you hold down Control key and click and drag on the name. You can pull it out, release it, and then hit delete, and that's a quick way to get rid of it. And it keeps your connections and everything, which is really nice. Be sure and have your mouse over the name part when you hold Control key down and click and drag, or you'll get frustrated if you try to click on the icon. It won't work. Okay, now the delays. Need to get rid of the delays. Delete. Control click drag, delete. I removed the wrong object down here, didn't I? Want the move object in there. Get rid of the release. Oh well, needed to get rid of both of them. Okay, now we need to have the wait for process end, or it's called wait for event activity. It's, let's see, this one here, wait for event. We want to slide that in after the move object. So, token's going to enter here. It's going to move the item, as referenced by token.item, into the inspection station queue, the queue. And then the queue is going to pass it to the processor. And then in our process flow here, we're waiting for an event. Well, you can imagine what event we'll be waiting for. We want to know when is the flow item done with its processing on the processor. And once it is, let it continue on. So, quick way to do that is use this eyedropper here. And make sure we're on the right one. Here's the inspection station. And the event we've learned to listen for to know when everything is done at the processor is the send to port event. And that's all we need to do. If we look at it, the object's the inspection station, the event is send to port, that all got filled in for us. We need to know that the event happened, and if it did, then send the token to the next activity. Let the token pass through. It's kind of a gate. Okay, well, I need to do that for all these. So let's get to work here. Wait for event. Slide that in here. This is the painting event, which is this guy here. And use the send to port. Okay. Again. Slide it up in here. Now, this curing's a little different. I'm going to stop here and add something to my model. I want all three of these processors to be in the same group, and then I can refer to the whole group when deciding where to move the object and what event to wait for. So, I can select them all with shift click drag, right click on any one of them, go to this menu here, object groups. This is a quick way to add a group and add all selected members to that group. Add a new group. We'll call it the curing group. It's made up of those three processors. It's a really handy modeling technique is to create groups. Okay, now on curing, well, the move, we moved it into the queue, and the queue will decide which one to pass it to. That reminds me, I need to create my connections in my model too, but we'll do that later. Okay, wait for event. Oh, let's do it the easy way. Click on this little exclamation point, get the sampler, hover over any one of the objects, and now I've got a choice. I can choose the slot itself or the group, and it's going to show me the same events because it knows the type of objects that are in the group, and I want to use the send to port. Perfect. That's done. Now continue on. Create a waiting for event. Slide that in, click this. This is cutting, not curing, cutting. It's this guy here. Choose to send the port. this inspection again. Slide it in. Click here. Click on the inspection station. Choose send to port. Polishing. Wait for event. Slide it up in there. Click here. Go to the polishing station. Choose the send to port event. And we're on the third part type here. Cutting. There we are. Wait for event. Slide it up here. Click here. Go to the cutting station. Choose send to port. Painting. Wait for event. Slide it up in. Choose the eyedropper and go to painting. And choose the send to port event. Curing. Click here. Go to any one of our curing stations here. Choose the group and send to port. And finally, inspection. And inspection station. Send to port. Okay. Remember I said I needed to do the connections. So we got some A click drag to do. A puts us in the connect mode. Click and drag from the queues to the station, corresponding stations. And in the case of this curing queue, we want to connect up all three curing slots. We'll connect them up in the order of their name. Okay, I think we're good. Let's save the model and reset and run and see what we get. Okay, we got an error. Oh yeah, okay, I forgot to do something. So let's stop the model, reset, close the error window. Alright, this is what I forgot to do. On these wait for event activities here, remember this part here that I didn't need to worry about when I was working on the smaller demo model leading up to this model. But in this case, where we have lots of flow items trying to use the same stations, and we've got them being controlled by tokens, we need to control things a little better. The way we're going to do that is by using this operation called match. What do we want to match? We want to match the flow item as referenced by the token's item label. We want to make sure that the flow item that just caused this inspection station send to port event to fire is the flow item that is matched up with this token. So the releasing item is the flow item. It needs to match up with what is recorded on the item label of the token. That's a second check that has to be made by the wait for event activity block before it will allow this activity to finish and pass the token on. Two things have to happen. The event has to occur, and this requirement that the flow item must match. So I gotta just go through and write item, and which is the name of the label, and the operation being matched to all of these. I can do that really quick. Choose match and paste that in there. Choose match, paste that in there, and do this for each of them. Hopefully that makes sense. If you need more explanation on that, there's some nice things written up about it in the online help or the user manual associated with the software that you can look up for this field called the label matching and assignment. Just search for it. Sometimes you use this to record information on a label of the token, and sometimes you use it for what we're doing here, and that is match up and make sure the token aligns with the object out in the model that caused the event to occur. And one more. Hopefully didn't make a mistake, got all those typed in. Okay, let's save this and try it again. Okay, looks like it's working good. Slow it down. Okay, looked like it was processing more than one at a time running fast, but you can see it's not really doing that. How many curing stations are used simultaneously? Rarely see 3. I've seen 2 though. Let's see, red is color index 1, so part 1 will be red, and then part 2 is green, part 3 is the blue parts. Looks like it's working. Another thing you can do is click on these tokens. It'll give you information about the labels. So it has a type label of 3, and this is a reference to the flow item that is associated with this token. You can click on this binoculars and it'll center up that flow item in the view and highlight it for you. So this is the flow item here that is associated with this token here. Alright, that concludes Model 2. We've finished all the phases, including both the simple and advanced options for Phase 5.